example 8 here is going to compare some exponential functions. So we actually have three functions right here. We have, a growth function right here. So it's probably like we're up right here, 1, 2. So this is probably up to, so that's up to, it might be like, that's a 0.2. So 1, 1, 2, 3. So it's probably like 3x. G of x is probably equal to like 3x plus 2. That's probably the equation, I'm assuming. So we have that one, and then we have these two others that are kind of one function, but they're made up of two pieces. It's called a piecewise function. So we're going to use this exponential decay, right, because we're 1/2, for anything less than -1. And anything from -1 and greater, we're going to use this linear equation. Okay, so if I graph these, right, we can graph this exponential. We're not going to use -1, like it's not actually going to be on point on our thing, but we are going to plug it in here, because when I plug in -1 as an exponent, that -1 flips that and becomes 2 over 1 to the +1, which equals 2. So if I plug in -1, I get 2, 1, 2. But since I can't actually use it because it's just less than, it's an open circle there. Okay, so I can use numbers to the left of that, right? So I can plug in -2. That negative is going to flip that to a positive, or 2 over 1, and now it's a positive exponent, so I get 4, right? So at -2, I'm at 4. There's 2, 3, 4. And then it's just going to keep on going up past that, right? So it's going to go up past that. I can plug in some more points. But it's an exponential function. I can plug in -3, I get 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. So it's something maybe like this. So it kind of looks like that. Excuse me. Then we have a linear for anything -1 and greater. So I can plug in -1. -1 times 2 is -2. -2 plus 4 is +2. So it does hit that point right there. And then we can plug in 0. So 0 times 2 is 0. 0 plus 4 is 4. 1, 2, 3, 4. Plug in 1. 2 times 1 is 2. 2 plus 4 is 6. So 1, 2, 3, 4, 5, 6. And it just keeps on going, right? Because it's linear. So it looks like that. So that function, maybe I should do a little bit better job here. So this one. All right, so it looks like this. That's terrible too. Jeez. Looks like that, right? 1, 2, 3, 4, 5, 6. Good. Okay, and then this side went for, that one didn't count, but it counts on this part, right? And then it's up here like that. So curve it a little bit like that. So that's what our kind of function looks like. Okay, so comparing these, we can see that this is an exponential decay. This blue one is an exponential growth. This one is a linear equation. Okay, so then we can also compare, relative mins, relative maxes. We can see here that our relative min for this f of x is at 2, right? So relative min, we have a point -1, 2, right? Where g of x, the blue one, it looks like it kind of has an asymptote right here at y equals 2. So it doesn't have a relative min because it keeps getting smaller and smaller and smaller. It's never going to cross at 2, but it's going to keep getting smaller. So it has no relative max. So g of x is none. And then we can look at, say, domain is everything, right, for both of these. Range, we could say the range for this one. The green one here, f of x, would be 2 and above, and including 2 though, because this one we can get 2, right? We did get 2. Where for g of x, it would be greater than 2. End behavior, as I go, these are both the green one, f of x. Our end behavior, as I go this way, it goes up, and as I go this way, it goes up. Where end behavior for the blue one, as I go this way, it goes up, but as I go this way, it approaches, gets close to 2 here. It gets closer and closer to 2. So you can say f of x gets closer to 2. Okay, so that's kind of some differences with end behavior. Y-intercept, this has a y-intercept of what? 1, 2, 3, 4. This has a y-intercept of 3. Right, so some differences there. Yeah, that's probably good on that one. So just comparing those, comparing the end behavior, comparing the asymptote, comparing the relative mins, comparing the y-intercept, end behavior. So that's what you're kind of asked to do on when you have more than one graph and you're comparing.